Okay. So I think my voice is audible to all of you. So very good morning to all of you. Myself, Saptoshi Sarkar from Electrical Department in Dugda Engineering College. And today is the third class of the Basic Electrical Engineering lab, and we will going to perform the second experiment from our syllabus. Okay. So first, we would like to go to our syllabus. Okay, so that we can a clear idea what lab today we will going to perform, right? So I'm opening the syllabus of your class. Oh, okay, I think I am opening the sharing the screen of the screen, and the syllabus is there. You can clearly see this is the your class syllabus. Okay, and basic electrical engineering lab ESC 101P. Already in the first experiment, this experiment we all performed in the previous lab. This in this
Sir,
class, yes, tell me.
sir, it's a request. Please, sir, speak loud, sir, louder, sir.
Okay, 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 no issue. Okay, thank you. Okay, note yourself. Okay, I am adjusting the volume also so that you guys don't have any problem. Okay. Hello. I think my voice is now louder. So in the
Yes, sir.
okay. So in the previous day, we already performed the experiment number one. Now today we will going to perform our 1, 2, 3, 4, 5 experiment number 5. This is very interesting experiment that we will going to perform. The name of the experiment is okay. The name of the experiment is demonstration of cutoff section. Demonstration of cutoff section of machines, DC machine, induction machine, synchronous machine, single phase induction machine. So demonstration of cutoff section of machine. Okay, this is we going to perform today. So what is the meaning of the demonstration of cutoff section of DC machine? What does this mean? Uh, this means nothing but a demonstration. Demonstration matlab description or introduction of the cutoff section of machine. What do you mean by the cutoff section of the machine? Cutoff section of the machine means we cut a portion of machine. We cut a portion of machine. Like if a whole machine is there, if we consider a whole machine is equivalent to 100%, then if we cut the 1/4 section of the machine, if we cut the 1/4 section of the machine, then then we call it the cutoff section of the machine. And what do you mean by the demonstration of the cutoff section of the machine? The whole thing, whole sentence is meaning is mean that when we read about the various type of machines like DC machine, induction machine, synchronous machine, then we read all the thing in the theoretically. In the practically also, we do not see how the inner part of the machine works or the how the inner part of the machine looks like. We cannot see in practical also because the machine is the inner part of the machine is does not open. Okay, so we cannot when all the things are joined together or rivet together or attached together. So we did not in the practically we did not see the internal part of the machine. But that's why the demonstration of cutoff section of DC machine experiment is there. In this experiment, we not only we discuss about the theoretical part, but also we discuss and see the inner part. How we cut a machine in the one fourth part or one third part, so that we know that what is the inner parts looks like. Like in the DC machine, field winding, armature winding is there. You know, So in the when we see a DC machine, we can see the inner part, we can see the winding. But when we cut a section of the DC machine, then we know the how the machine is looks like in the internally. So we can get, we can know the, we can understand the working principle, we can understand the construction in very well manner when we cut the section of the DC machine. So that is our today's aim of the experiment. Okay. Okay. Now, today experiment we will going to divide it in two parts. First part, one part we will discuss, we will see the video, we will see the cut-off section video from the YouTube, and I will describe line by line, you guys. And second part, we will see a PDF, okay, where the cut-off section of every machine described point by point. Okay, now go to first. I think if we see a video, then it might be helpful, right? So section. We divided the class in two portions. First portion we see the video so that we have the better idea. After that we see a PDF or slide of this particular experiment. Okay, I'm opening the YouTube and describe everything. Okay. I think my screen is visible to all of you. Hello, confirm me. I think my screen is visible to all of you.
Yes, sir.
Okay.
Yes, sir. Yes, sir.
There will be no sound. There will be no sound. Only you see the video, and line by line I will describe what happened in the video. In the video, you can see the cutoff section, the internal part of the every machine. We discuss about the three machines: DC machine, synchronous machine, and induction machine. First, we will start our experiment with the DC machine. Okay, you guys see the video. Okay, this is the okay. So I think my screen is visible to all of you. So in the screen, you can clearly see that this part, this is the field section of the DC motor. So every machine, listen to me very carefully. Every machine has two parts, two main parts. One is rotating part. One is static portion or stator. One is rotor, one is stator. Every machine have every rotating machine have two parts. One rotor, one stator. Okay. So in the stator, we place stator winding. In the stator, we place stator winding or the field winding, and in the rotor, we put the armature winding. So in the stator is the field winding is there, and the rotor, the armature winding is there. But when we talk about the field winding of DC motor, field winding, what is the purpose of the field winding? Can anyone know? The purpose of the field winding is nothing but a produce a electromagnetic field. Electromagnetic field. Electromagnetic field. In the picture, you guys can see that this is that this N and this S, both are represent the stator. Both the represent field winding. Both the represent field winding. So what is the purpose of field winding? They produce a magnetic field, because when we talk about a rotating magnetic field or electromagnetic induction, then we must generate a electromagnetic field. Okay. फर्स्ट हम लोग का फर्स्ट काम क्या है? इलेक्ट्रोमैग्नेटिक फील्ड जनरेट करना. इलेक्ट्रोमैग्नेटिक फील्ड हम लोग कैसे जनरेट कर सकते हैं? हम लोग फील्ड वाइंडिंग से. फील्ड वाइंडिंग मतलब सर क्या होता है? फील्ड वाइंडिंग मतलब कुछ नहीं होता है, जस्ट वी wound a coil in a proper manner. So when we pass the DC current through this coil, field coil, then electromagnet, they produce the electromagnetic field. Okay. सर इसका एक एग्जांपल दीजिए, कुछ समझ में नहीं आ रहा. ओके. तुम लोग घर एक छोटा सा एक्सपेरिमेंट घर में कर सकते हो. जब हम लोग एक कॉपर कॉइल तुम लोग जानते हो, कॉपर कॉइल को अगर हम एक रिंग की तरह, कॉइल की तरह थोड़ा सा ऊंड करें, और उसका जो दो टर्मिनल है उसको अगर एक हम लोग को जो बैटरी है जो वॉल क्लॉक में लगता है, उस बैटरी के अंदर कनेक्ट कर दो. टू पोर्शन ऑफ द ऊंड कॉइल ऑफ द स्मॉल, छोटा सा एक कॉपर कॉइल को ऊंड करे, एक कॉइल की तरह रिंग करे, और उसका दो टर्मिनल, बैटरी का दो टर्मिनल के साथ अगर कनेक्ट कर दे हम दोनों, तो क्या होगा? एक उसके अंदर से जब करंट फ्लो होगा तो एक मैग्नेटिक फील्ड क्रिएट होगा, एक मैग्नेट क्रिएट होगा, इलेक्ट्रोमैग्नेट क्रिएट होगा. एंड दैट इलेक्ट्रोमैग्नेट कैन अट्रैक्ट द आयरन, जो मैग्नेट आयरन को अट्रैक्ट कर सकता है. ठीक है, तुम लोग एक्सपेरिमेंट को देखे हो शायद, नेट में हो.
Okay, sir. That will behave like magnet, copper wire, na sir?
Yes. When the copper coil, when the current is passing through the copper coil, then it behaves like a magnet, right? Exactly. So similar thing happen here. Similar thing happen in the DC machine also. So हम लोग इलेक्ट्रोमैग्नेटिक फील्ड चाहिए. तो इलेक्ट्रोमैग्नेटिक फील्ड लाने के लिए क्या करना होगा? Either we will create an electromagnet, otherwise other option is that we use a permanent magnet. In the picture you can clearly see this is the permanent magnet. No coil is here. This is the permanent magnet. We can put the permanent magnet, but there are some negative side of the using the permanent magnet. You guys all know that after some time the magnetic property of the magnet is losing, right? The magnetic property is losing by the time. Okay. And if the magnet is damaged due to any erosion, due to any reason, it get damage, or due to the time, the magnetic property of the permanent magnet, magnetism property of the permanent magnet is decreased due to time. Okay. जैसे हम लोग हमारे पास घर में हम लोग क्या करते हैं, वो जो स्पीकर के पीछे मैग्नेट होता है ना, उसको हम लोग लेके खेलते हैं, मगर वो जो हाथ से गिरता है बार बार, तो क्या होता है? उसका मैग्नेटिक प्रॉपर्टी धीरे धीरे कम जाता है। ओके, ठीक है, मैग्नेटिक प्रॉपर्टी धीरे धीरे घटता है। तो इन द स्टेटर पार्ट, okay, in the stator part we just put where there are two options is there. One, we can put the armature field coil, और उसके अंदर से हम लोग जब when we passes the DC current in the field coil, then we can produce a magnet, or we use the permanent magnet. Okay, after that you can clearly see here in the permanent magnet one magnetic field. The magnetic field is produced. The uh, yellow color line is there, is the magnetic field. Okay, so in the magnetic field, we put a coil. In the magnetic field we put a coil. See the video and I will describe line by line. Okay, so in the DC machine, in the rotor part, we already discussed the step part. In the DC machine rotor part, you can clearly see one coil is there. One coil is there. This is not the one coil. We use many coils, but due to the understanding, we put one coil here. This is the one coil. Okay, and this coil is connected with the commutator. This is the commutator part, and behind the commutator, this is the brush. This is the brush, commutator and brush. Okay, so this coil is attaching with the commutator and brushes. Okay, if the meeting is off automatically, June time limit is going to off. If the meeting is off automatically, please join again using the same link. Okay. Okay. Now please see. Okay. So coil is rotating in the rotor part. Okay, and it cuts the magnetic field. Coil it's rotating in the rotor part, and magnetic field. The purpose of this coil is to cut the magnetic field. Okay, and the coil is connecting with the commutator and brushes. Okay. Okay, so in this position, you can clearly see when this armature coil or the rotor coil is perpendicular to the magnetic field, then torque is zero. Then torque is zero. Okay. Okay, and when it is perpendicular, then torque action is zero, and it cuts the less amount of magnetic field which is produced by the field. And when it is the horizontal, when it is the horizontal, then it cuts the maximum flux. Okay, you can clearly see in this picture also. ओके, सो अगर अगर हम लोग के पास जब ये परपेंडिकुलर, ये एक कॉइल था, ये एक कॉइल जब परपेंडिकुलर था, तब क्या कर रहा था, तब ये मैग्नेटिक फील्ड को कट नहीं कर रहा था, इसलिए टॉर्क एक्शन जीरो था। जब ये हॉरिजॉन्टल आ गया था, तब क्या कर रहा था, तब मैक्सिमम अमाउंट ऑफ फ्लक्स इज कट, बट देयर विल बी इरेगुलर मोशन, क्योंकि एक टाइम में ज्यादा फ्लक्स को कट कर रहा है, एक टाइम में कम फ्लक्स को कट कर रहा है, सो देयर विल बी ए इरेगुलर मोशन इज देयर। बट व्हेन वी वांट टू minimize the irregular motion of the rotor of the DC machine, then we must add another coil. When we must another coil, क्योंकि हम लोग जितना ज्यादा कॉइल को ऐड करेंगे तो क्या होगा, अगर एक कॉइल, अगर we add the two coil, you can clearly see in the blue line one coil is there, and the copper and this copper yellow color, this one another coil is there. जब एक कॉइल परपेंडिकुलर पोजीशन में रहेगा तब तो टॉर्क एक्शन जीरो रहेगा, मगर जब एक कॉइल परपेंडिकुलर पोजीशन में रहेगा तभी एक उसी टाइम में अरे और एक कॉइल, क्योंकि हम लोग दोनों कॉइल ऐड किए, और एक कॉइल क्या होगा, हॉरिजॉन्टल में रहेगा। हॉरिजॉन्टल में रहेगा तो क्या होगा, जब एक परपेंडिकुलर में रहेगा, कोई फ्लक्स कट नहीं करेगा, तो दूसरा कॉइल फ्लक्स को मैक्सिमम अमाउंट में कट करेगा। ठीक है, तो मेरा मोशन, इरेगुलर जो मोशन, तो वी मिनिमाइज द इरेगुलर मोशन, सो वी गेट द स्मूथ मोशन, we get the smooth motion by the adding the more coil in the rotor of the DC machine. Okay. So in this position, when one loop is in the vertical position, then other loop is in the horizontal position, and it is connected with the current source. It is connected with the current source. The current source is connected with the commutator and brushes. Okay. This is the carbon brush. Okay, and behind the carbon brush, one spring is there. So that is carbon brush is due to the friction. It is ये थोड़ा थोड़ा करके ये घट जाता है. तो this spring is held to carbon brush attached to the commutator segment. Okay, which is the commutator segment. Okay. So the motor forces always present in the system. Okay, in this way. If the meeting time limit is meeting is ending automatically, please join again within the same loop. Okay. This experiment is going to be very interesting. You know, a clear after this class, you know the clear idea about the various type of machine. Okay, so don't miss this class. Okay, so in the motor, you can in the motor what happens. So in the practical motor, the rotor coil in the practical motor, the rotor coil is placed a high permeability মানে মানে slot of মানে rotor coil is placed the slot of the high permeable material. So this material is also the characteristic of this material is this is a high permeability material. So high permeability material means so that it gives the flux. It gives the flux a good path to contact. High permeability means that a metal that gives the flux a, a good path to contact. Like current. Current is conducting in copper coil very easily. If we conduct the current in the wood, it cannot conduct. But if you use the instead of wood copper coil, the current can conduct very easily. That in the same thing happens in the also in the flux, that when you conduct, when you place a high permeable, if a high permeability metal, then the flux can easily going through or get a good path. Okay, so you can clearly see this is the high permeable material, and flux can easily conduct throughout the this material. Okay, so so that this coil, rotor coil, can easily cut the this flux. Okay. Okay, and also I describe that behind the carbon brush, one brush is there. Okay. Okay. So you can clearly see that in the small motor, like in the toy. in our house, many toy car is there. In the toy car, also DC motor is there. We also many we also play with the many toy car like remote control car. They also have the DC motor. Okay. So in the DC motor, small DC motor, we use the magnet, permanent magnet. But in the large DC motor, which is uh, which is used in the industry or the factories, then we use a electromagnet in the field of the DC motor. You can clearly see this is the field winding of the DC motor, and also there are two ways we connect the field of the DC motor. One is series, one is parallel with the rotor winding. When we connect the DC motor field winding with the rotor winding in series, then we call it is a shunt motor. Many times interviewer asks you that what is shunt motor? Shunt motor is nothing but a the parallel is the parallel connection between the DC motor stator winding and rotor stator supply and rotor supply. Stator winding and rotor supply, they are connected with the parallel to each other. That's why it is called the DC shunt motor. And also, if we connect the DC this field winding with the armature winding in the series, then we call it is the series motor. Also, there will be a compound motor is there where we connect series and